Hi, I'm Belly from Greenwood Solutions. Glasses, laptop, yeah, it's spreadsheet time. Today we're going to be looking at an AC cable schedule. So we're looking at the current going through the cable and the volt rise calculation from a spreadsheet perspective. And at the end of this, hopefully you'll understand a little bit more about volt rise and be able to use this spreadsheet for your next commercial solar project. So let's get stuck into it. Hit that subscription button too. So today we're talking about an AC cable schedule. So Veli, why would I need an AC cable schedule? Answer, if you're doing a commercial solar project, you need to know and you need to document what kind of cabling you're using, what the cable run is, where it's going, and what the volt rise is along this run. First thing, cable run number. So we're talking about the cable run number, and obviously the first one is number 1. The first position is the start position, and in this case, it is at the point of supply. So that's the start position, and then the cable end position, in this case, is the main switchboard. You've been on site, you've identified the cable type. Now the size of the cable, in this case, is 400 mil. Now I've done a little bit of a drop-down list, so you've got 4 mil all the way up to 400 mil, and everything in between. The next cell is, can the cable carry the current, yes or no? I've used data validation here to create a bit of a warning. So effectively it says CCC, current carrying capacity of cable. Make sure you have taken into account different installation scenarios and apply the appropriate D rating. So the current carrying capacity, the CCC of a cable, is incredibly important. So make sure that the cable in question can carry the current of your particular solar project. Now this question, are you using parallel cables? And in this case, no. So cable run in meters, 150 meters, and you can input whatever you like in here. Usually I do the inputs in yellow, but because there's a bit of information on the screen, I decided not to. So the current through the cable, and I've done a little bit of a data validation scenario here as well. So I've said check combined current from all inverters applicable. For example, 100 kilowatts inverters would mean 100,000 watts divided by, in brackets, 400, which is the normal voltage of a three-phase situation, times 1.732, which is the square root of 3 because it's three-phase, comes out at 144.34 amps. Normal voltage obviously is 400 in this situation, and now the volt rise. So, now with the volt rise, I've used the calculation that JCalc has used. There's a lot of different ways to do volt rise. In my earlier presentation, I was using the millivolt per amp meter method, which is referenced in the Australian standard that references AS 3008. So volt rise along this run. So what this spreadsheet does, it calculates the volt rise along the particular run, and then in the next column you're looking at the cumulative volt rise. So in this case here, you can see it's 0.9 because there's nothing before it. But over here, the cumulative volt rise is this figure plus this figure. Okay, now let's go back to the original example. A VLOOKUP, so we've looked in what's in F4, that's the cable size. Now we come across to this table here, and effectively what VLOOKUP does is it says, I'm looking to see what's here, right? I'm looking at this reference here, and I want to extract the information from here. So you can see here T3 to U18. Now, we're not looking at cable resistance because it's AC, we're looking at the cable impedance. So the resistance value is slightly smaller than the cable impedance value. So it looks across there and goes, okay, the cable impedance there is 0.096. So it looks in column 2, as I said, down here, and I've got a false, I put false in there so it gives you a correct figure. And then it multiplies that by the square root of 3, which is a three-phase volt drop calculation, multiplies that by J4, which is the current, and then multiplies that by I4, which is the run. Now, unlike the DC volt drop calculation, you don't multiply by 2 because in three-phase, you're talking about per phase, right? So you're looking at the cable run in meters, then you're multiplying that by 1,000, of course, because cable impedance and resistance is per kilometre. And then to get the percentage, you're dividing back into the nominal voltage. So that's a bit of a mouthful there. There's a bit going on. Spend the time to have a look. Now, what I've done over here is I've got the JCalc hyperlink. So we'll click on that. So we've got the voltage of 400, we've got three-phase AC, we've got the correct load rating, 144.35 amps, we've got a cable size of 400 mil, and we've got a distance of 150 meters. And the calculation I've used in my spreadsheet is the same. So here, 144.35, that's the current. 150, that's the run. Square root of 3, because it's three-phase. Divided by 1,000, yes. There's your volt rise, and then the calculation is 0.9% for the percentage volt rise. Go back to here, you can see 0.9%. So it's a pretty simple table. Always check when it comes to volt rise, make sure that you take into consideration how you're installing the cable, and that can play a big difference both in current carrying capacity and volt rise. This calculation assumes not worst case scenario, but fairly close. For more accurate calculation, you really have to go through AS 3008 and sort of do it manually, or spend the time to get the information into a VLOOKUP situation. Thanks for watching our presentation on AC cable scheduling via a spreadsheet. I know you love spreadsheets. If you have any inquiries, any questions, any answers, please feel free to drop us a line and hit that subscription button. I should have said. Thanks very much. Bye.